All right, here's our study guide. This study guide is good for Wednesday's test. It's also going to be good for going forward and much further after that. Here's number one. Donna and Darcy, they collected newspapers for recycling. All right, Donna collected 5/3 pounds of newspapers. All right, 5 3/4. So Darcy collected 2 1/4 pounds. What was the total amount? Total amount they collected. Now, when you see that, total amount can mean many different things: add, subtract, multiply, divide. But if you look at it, if two people collected a certain amount of an object, and then it wants to know how much is that all together, that's adding. So we will be adding these. So you take the two numbers, 5 3/4 plus 2 1/4. All right, as soon as you do that, you'll notice that you already have your like denominators. That's great, but I still want to set it up the right way, which is we put this big plus sign. I call it the 4S chart. All right, so with this 4S chart, 3/4 and 1/4, you could just go ahead and add together. You're supposed to skip count right here, skip count. But we don't really have to because we have our like denominators. So we're going to skip this one. We're skipping skip count. All right, substitute and solve. We'll solve. Okay, so 5 plus 2 is 7. 3/4 plus 1/4 is 4/4. 7 4/4. Simplify. All right, well, if you ate 7 4/4 of a pizza, you ate 8 pizzas. 8 pizzas. B. All right, moving on. Number two, which fraction is equivalent? When they say equivalent, it means equivalent to the answer. So it might be a simplest one or not. You just got to look for it. But equivalent to 5/6 divided by 1/3. 5/6 divide by 1/3. All right, the rules when you're multiplying and dividing fractions are: the first rule is to have no whole numbers. All right, there's no whole numbers. Cool. And then what is the second thing to do? If it's division, you only do this for division. And what is it called?
Multiply.
Yeah, we got to turn it into multiply. And how do we turn it into multiply?
KFC.
Keep, flip, change, KFC. Absolutely. So I'm going to go ahead and write that underneath it. Keep, flip, change. And that would give me 5/6. Flip it to multiplication and make it 3/1, the reciprocal of 1/3, 3/1. So 5 times 3 is 15. 6 times 1 is 6. Yes, we could have butterflied that a little bit, but it's okay because I know a lot of times we're going to forget that. So unless we see really big hard numbers that makes us pause, we're going to keep moving. All right, so 5 times 3 is 15/6. All right, remember, if it's an improper fraction, or a big-headed baby as we call it, an improper fraction means long division. A proper fraction that you're simplifying is short division. So proper, simple. Improper, complex. Long division, you know. All right, so here we go. 6 on the outside, denominator at the door, numerator in the house. 6 goes in the 1, can't do it, but 6 goes in the 15 2 times. All right, once we have that, we can multiply because that's the D in divide for does McDonald's sell burgers. All right, so we divided 6 into 15, got 2. All right, multiply. 2 times 6 is 12. Now we get to subtract them. 15 minus 12. Well, 5 minus 2 is 3. 1 minus 1 is nothing. So 3. That's the subtract. Nothing to bring down. We're not dealing with decimals, so we don't have to put decimal, 0, 0, 0, decimal, or any of that. All right, so 2 and 3, 6. 2 and 3/6. Here's our problem, though. If you look over here, you'll notice there is no 3/6. You see a 2, but that's a half. Oh, look, I think this would become half if you took the greatest common factor of 3, divided the top and bottom by it. That's called simple division. Remember, we said long division and short division. This is that short division, the simple division. All right, 3 divided by 3 is 1. 6 divided by 3 is 2. 2, bring it over, 2.5. D. I'll keep number 2 in the window. I'm going to bring it up just a tiny bit and start discussing number 3 a little bit. Please make sure you get number 2 written down. Get everything written down. All right, number 3. Jasmine's recipe requires 2/3 cup of flour. Requires 2/3 cup of flour. She only has half a cup of flour. How much more? How much more flour does she need? So how much more? If you had $10 and I had $5, how much more dollars you have than me? You would take your 10, you would subtract my 5, and it would leave you 5. So it would be subtract. How much more means subtract? All right, so we take the 2/3, we take away the 1/2. Now, since this is an add or subtract problem, put your big plus sign. Add or subtract, you put a big plus sign, because now we get to skip count. All right, so 2/3, 1/2, 2, 4, 6, 1, 2, 3. Now 2/3, 3, 6 is good. 3, 6, 2, 4, 4, 6. So we have 4, 6, and 3, 6. That's my new 2/3 and 1/2. All right, so now I get to substitute / solve. All right, I'm substituting 4, 6 for 2/3. So 4, 6. 3, 6 for that 1/2. So 3, 6. And it was a subtraction problem. 4 minus 3 is 1. 6 minus 6, you don't do that because it's a least common denominator, so it just slides over. It's the same all the way through. So 1/6, which does not simplify any further. So D, 1/6, would be the correct answer for number 3. Number 4, simplify the following expression. Enter your answer in the box provided. Simplify, solve it. So 3/2 times 3/4. All right, I have no whole numbers. That's the first thing. When you have multiply, divide, no whole numbers allowed. Exclusive club of fractions only. All right, so if you have no whole number, you go to the next thing. It's not division, so there's no KFC. I get to either butterfly or multiply across. I'm going to go to multiply across. 3 times 3 is 9. 2 times 4 is 8. Then you go, oh, big-headed baby, ding, ding, ding. Going to have to do our long division. Improper, long division. Proper, short division. This is improper, so long division. The 9's bigger than 8. So 8 goes into 9 one time. 1 times 8 is 8. Subtract, and you get 1. So you have 1 whole and 1/8. So 1 1/8. Now remember, when you're writing this in this box on a computer, you have to put a 1 space 1/8. I want to be careful with that, because if you just put 1 1/8, that's 11/8. It's not the same as 1 1/8. That is actually a different answer completely, and you would get it wrong. So be very careful with that. I'll leave this up here for a minute, and then I need to get moving. Yep. Hmm?
Like right now?
Yeah. All right, about to go ahead and move forward. If you still need some of this, go ahead and at the end I can go back to it or get it from a neighbor. All right. Now this one I'm going to zoom in on some because it's really hard to see way up here in the corner. 1 5/6, so 1 5/6 minus 1/3. All right, so this is an add subtract, so draw your big plus. The 4S chart, as we call it. All right, this is where we skip count. I'm going to start using abbreviations. Skip count is SC, skip count. That way we've already wrote skip count on the other side, so we don't need to keep doing that. All right, so I'm going to skip count 5/6. Well, 1 5/6, or 1/3. Well, I'm going to do the 3 first. 3, 6, 1, 2. So 2/6 and 1 5/6. So I get to use those. So now I'll substitute / solve, S/S. 1 5/6. All right, still subtraction. See, subtraction in the original problem, still subtraction. 2 6, 2/6. All right, 5 minus 2, 3. 6, bring it over. 1, bring it over because there's nothing to subtract it by. 1 and 3/6. Divide the top by 3 and the bottom by 3. Remember, proper division, proper fraction, short division. Improper fraction, long division. This is proper, so we'll short divide it. 3 divided by 3 is 1. 6 divided by 3 is 2. 1, bring it over. 1 and 1/2, C. 1 and 1/2, C. All right, here's the next one. We got, look at the table, it says, and we look at James' weekend activities. Well, his weekend activities was cleaning his room, washing dishes, doing homework, cleaning bathrooms, and folding clothes. He did it for these lengths of time. All right, in hours. 1 and 2/3, 1/4, 2 and 3/4, 1/3, and 1/2. Now it says estimate the closest to the amount. Estimate to the closest to the amount. Well, let's first try to figure out if we can put some of these together without doing a lot of hard math. We don't really need to find 1, 2, 3, 4, 5 like denominators. To find one like denominator that works for all those, that takes some time and be annoying. There's no reason to do it. All you have to do is figure out which ones can match up. Which ones can match up. So, here we go. 2/3. 1 and 2/3. Do I have anything else that has a 3 on the bottom? Let's look. No, 4, 4, 3. All right, so I have 1/3 and 2/3. 1/3 and 2/3. Well, so let's add those. 1 and 1/3 plus, or 1 and 2/3 plus 1/3. 2 plus 1 is 3. Denominator stays the same because I found them with like denominators, and the 1, bring it over. 1 and 3/3 is the same as saying 2. So these together would equal 2. So I got 2. I'm just going to place it on down there as one of my numbers that I'm going to be adding. All right, and now 1/4. Well, let's see if I have anything else with fourths. Oh, there it is. 3/4. Well, 2 and 3/4 plus 1/4. 3 plus 1 is 4. 4 plus 4 is 4 because we keep the denominator the same. 2 plus nothing is 2. So 2 and 4/4 is the same as saying 3. So plus 3, cancel these out. And now all I have left is this 1/2 right here, 1/2. All right, so 1/2. So 2 plus 3 is 5. Plus 1/2. Well, that would just be 5 and 1/2. All right, one little problem. I don't have 5 1/2 down there. I have 6, 10, 3, and 1. Which would be the closest? Would 6 be... would 10 be the closest? No? Okay, well, how about 6? Yes. Yeah? You can say yeah? Yeah, okay, cool. Yeah. It would be 6, absolutely. 6 is the closest one here to 5 1/2, without a doubt. 1/2 actually rounds up because that would be 0.5 as a decimal. 5 and above, give it a shove. So that would actually make it 6.0. So that works out. And we did all that without finding common denominators. Instead, well, I did find them. I just found them within there. They had thirds, they had fourths, and then they had a single half left over, which was easy because we just threw it on the end. Yes? Okay. All right, moving down to number 7. We have seen number 7 probably 3 times now, I think. All right, so this one's a common one for us, but it's a good one. All right, it's an oldie but a goodie. A farmer has 6 cartons of specialty eggs for sale. Each carton contains 1 dozen. So 6 cartons of 1 dozen. So 6 times 12 equals 72. So we have 72 eggs. If 2/3 of the eggs are brown, 2/3 of means multiply. The eggs, the 72, are brown. What is the total number of brown eggs he has for sale? So how many brown eggs? Well, 2/3 of the eggs are. Well, the eggs are 72 because 6 cartons, 6 objects, 6 cartons that each hold 12, each one hold 12, 6 times 12 is 72. So because there's 72 eggs in all, 2/3 of them, 2/3 times them. So let's set that up. 2/3 times 72. First things first, put a 1 under it. Now, like earlier I said that I only butterfly with really big ugly numbers. This is a really big ugly number. All right, so let's deal with it. Butterfly. Well, 2 and 1 you can't really do anything with. So 2 and 1 will stay the same. All right, but 3 and 72. 3 goes into 3 one time, but 3 goes into 72. Let's find out. If you're not sure, let's type it in. 3 goes into 7 2 times. All right, that's divide. Now multiply. 2 times 3 is 6. All right, that's DM. Now subtract. 7 minus 6 is 1. And now B for bring down. 3 goes into 12 4 times. 4 times 3 is 12. Nothing. So 24. So 2 over 1 times 24 over 1 equals 48 over 1. Or as we like to call it, just 48. Now, those of you that did not want to do all that math, there is a way around it. Since this is our third time seeing this problem, I think it's about time I tell you this. All right. Logically, it makes sense. So if it says 2/3 of the eggs are brown, you do have to figure out how many eggs there are. That's 72. So 2/3 is 72. Okay, 4 and 8 is nowhere near 2/3 of 72. Think about it. I mean, 2/3 means more than half. More than half of 72 would not be 4 or 8. You can look at 4 and 8 and say, I know that's not more than half of 72. All right, well, look at 72. 2/3 of 72 isn't 3/3 of 72. It's not saying a whole 72. So it has to be less than 72. So if it's less than 72, but more than 4 over 8, or 4 or 8, there's only one choice, and that's 48, which sounds about 2/3 of 72. So that's pretty good. So that's the mathematical way, and then you can kind of think your way through it, because you will hit roadblocks. You'll stop, you'll stare at it, you'll tilt your head sideways, you might open your mouth a little and go, and that's okay. You just pick yourself up by the bootstraps, keep moving. Don't get stuck. There's a million ways to solve these, and I'm showing you a bunch of them. All right. I got to keep moving, guys. If you need this, I'll hook you up after. All right, distance Frank walked. We got to talk about Frank's walking problems. Here we go. So he walks Monday, Tuesday, and Wednesday. In miles, he does 3/4 of a mile on Monday. He does 1.5 miles Tuesday and 2/3 of a mile on Wednesday. According to the table, total distance. Total distance means add them up. 3 over 4 plus 1 1/2 plus 2/3. All right, now it's an adding problem, so add or subtract. Go ahead and make the big X or a big plus sign. 3/4 for skip count, 1 1/2 for skip counting, and then 2/3. Well, I'm going to start with the smallest one, 2, 4. Well, there's 4, but got to keep going until something the 3 can fit into also. 6, well, the 3 can fit in there, but now no longer can the 4. How about 8? Nope. 10. 12, there we go. 1, 2, 3, 4, 5, 6. So 1 6/12 is one of them. And then we have 3/4, 4, 8, 12. 3, 6, 9. 9/12. And then we have 3, 6, 9, 12. 2, 4, 6, 8. 8/12. So I have 9/12, 8/12, and 1 6/12. So now I'm substituting and solving. 3/4. 3/4 is now 9/12. All right, plus 1 6/12. Plus 8 over 12. All right, the 1 whole, if you want to just bring it out, you can do that. Just say, oh, it's going to be 1 plus something. All right, now you have 9 plus 6, which is 15. So 15 over 12 so far. Plus 8, 15 plus 8 is 23. So 23 over 12. So 1 23/12 is what we're at so far. Well, let's go ahead and do long division, improper fraction. 12 goes in there one time. That'll give you 12, and then it gives you 11. 1 and 11/12. But don't forget about that first whole number that was there, so 1 plus 1. So this is really 2 and 11/12. 2 and 11/12. All right, solve, express your answer in simplest form. All right, division. Multiplying or dividing, no whole numbers allowed. We got to get rid of them. Don't have a choice, we got to get rid of them. All right, so let's go ahead and make that happen. 2 4/5 divided by 5 3/5. Texas, Before you can eat KFC, you got to go to Texas. All right, 5 times 2, 10. All right, 10 plus 4 is 14. Same denominator, that 5. Still division, because I'm not ready to say multiply yet, because then I have to flip it also, and I'm not going to do that at the same time that I'm Texasing. It's kind of hard. I'll mess it up more likely than not. 5 times 5 is 25. Plus 3 is 28 over the original 5. Now I can flip it. KFC. 14 over 5 times 5 over 28. Now this is one of those big ugly numbers I talked about earlier when I said I would want to butterfly. This is definitely butterfly worthy. And you can do it both ways on this one. 5 and 5. Well, 5 goes into 5 one time. It goes into 5 one time. 14 goes into 14 one time. It goes into 28 2 times. So this would equal 1 over 1. That's the new fraction that would be over here. 1 over 1. Still times. And this new fraction instead of 5 over 28 is 1 over 2. And that would give me 1 over 2. So 1/2 would be the final answer, which is A. All right, this next one is what they call a process question. You'll always see one of these, at least one of these on each CSA, and I know this next one will have one, I believe. Now look down here. Process question means instead of you just solving problems, giving answers, regurgitating the information, it wants to know if you actually understand how you got there. So like when I tell you Texas, you guys can easily say, I got to Texas that. But if I said, what is Texasing, I'll get a lot of blank looks because you actually have to explain what Texas means. And that's what this is saying. And this is one of them. The one at the very bottom is what Texas is. And it says to multiply and divide mixed numbers, you first change mixed numbers into improper fraction. Texas takes a mixed number, it turns it into an improper fraction. That's what Texas is. All right, so that's what we're going to do is talk about which ones of these are true. So to estimate fractions, round to the nearest whole number. Sounds logical. Yeah, that works. True. To multiply fractions, change all the fractions to like denominators. Do I need like denominators to multiply or divide fractions? No, it's only for add or subtract. So they're trying to get you. That was trying to get you right there. That's clever. All right. When subtracting mixed numbers, it's sometimes necessary to rename the whole number into fractional parts. So if I said instead of 2 pizzas, you had 1 5/5 of a pizza, so I can subtract 4/5 on the other side, that's called regrouping. That's what that is. We've never seen it written out, but that is what regrouping is. You're renaming, regrouping. You see renaming, think regrouping. All right, so that's true. It's actually true. All right, next one. To divide fractions, add the reciprocal. When you're dividing fractions, you do deal with the reciprocal, but do you add it? What do you do to it? I mean, what are you doing with it? Are you adding the reciprocal or do we multiply by the reciprocal? Multiply. Yeah, multiply by the reciprocal. All right, because we turn division into multiplication. So that's true or false. Do not add. You would multiply. Add fractions. Add the numerators, then add the denominators. Do we add numerators? Yeah, do we add denominators? No, never add never. I don't care if it's add, subtract, multiply, or divide. At no point you should technically be adding denominators. That never happens. All right, so false. When subtracting the mixed numbers, first change all the fractions to like denominators. When I add or subtract, do I want LCD? Yes. Yes, that's true. All right, and to multiply or divide, change all mixed numbers to improper fractions. This is Texas. If you want to write that off to the side, that's Texas. If you want to remind yourself another time that that's what we do, that's called Texas. All right, and that's true. All right, we're making great time, guys. We're almost there. Let's keep going. Number 11, lava blocks. Oh, how I miss lava blocks. I love lava blocks. All right, start with your darkest shaded corner. That would be the bottom left one in this case. So 1, 2, 3. 1, 2, 3, 4, 5, 6. Says, which multiplying fractions is that? Well, this has 3 and 6, so it can't be this one. Could be that one if the 6 was times 3, but then that doesn't make sense. Nope. 6 and 3, 6 and 3. It's going to be the first one or the last one. Let's find out. All right, so 1, 2 out of my 3. 2 out of 3. Well, this says 1/3, so this says 2/3. 2/3. And then 1, 2, 3, 4, 5 out of 6. 5 out of 6. All right, well, 2/3 and 5, 6. 2/3, 5, 6. It has to be D. All right, next one says a media survey reported that in one evening, 2/3 of all U.S. households had their TVs on. And 3/8 of those with it on were watching the World Series. Using the rectangle below to make a model that represents the fraction of U.S. households who were watching the game. All right, so it says 3/8 of those with it on. Well, which ones had it on? 2/3 of the country. So 2/3, so 3/8 of the 2/3. 3/8 of those 2/3. 3/8 of 2/3. That's what we have to model. That's what we have to turn into a model. All right, well, I need thirds and I need eighths. Well, to get thirds, you just need 2 lines. 1, 2. All right, so that's 1, 2, 3. Oh, man, awesome. Now I got to get to eighths. That's not going to be as easy because I got to split it up by 7. 1, 2, 3, 4, 5, 6, 7. All right, now let's count those at the top. 1, 2, 3, 4, 5, 6, 7, 8. To let you know, on Wednesday, you will not be asked to make one of these. You do not have to make your own on Wednesday, but you will by the SOL. So we will practice this every now and then. All right, 2 of the 3. So out of these 3, 1, 2 of them make it across the lava. All right, 2/3. Cool. Now, out of the 8, 3 of them do. 1, 2, 3. Out of 8. So let's figure out how many are double crossed. 1, 2, 3, 4, 5, 6. Out of 8 times 3 is 24. So 6/24. Which 3 times 2 is 6. 8 times 3 is 24. So that makes sense. That's how it would look. All right, this next one. This one's, you've never seen one like this before. So this is a little different. And what they did is it kind of walks you through the problem. It kind of walks you through the problem, then it asks you something very simple at the end. And that's what we're doing. All right, so find 1 divided by 1/5. Start with the model of the dividend. 1, the dividend. All right, there's 1. Cool. All right, now it says rename the 1 as 5/5. So the fractions have common denominators. That means you're splitting it up into fifths. So 4 lines. So they took this one whole bar, split it up with 4 lines. All right, so we have the 1 whole and we have the fifths. Now it says circle all the groups with that divisor numerator right there. That 1. How many groups of 1 are in here? 1, 2, 3, 4, 5. So 1 divided by 1/5 equals 5. And we can double check that mathematically. All right, so 1 divided by 1/5. 1/1 divided by 1/5. Or, if you KFC it, 1/1 times 5/1 equals 5/1 equals 5. So, visually, mathematically, it makes sense. So now you get to see it both ways. All we did was split the 1 whole bar into fifths because you're seeing how many 1/5 exist within a whole. Well, if it's 1/5, there's going to be 5/5. All right. All right, last view, last page, front and back right here. All right, this one, you've never seen one like this one either. This is a really weird way they asked it, but it's interesting. It's good to see new ways because it makes us think. All right, a neighborhood garden that is 2/3 of an acre is to be divided into 4 equal-sized areas. What's the size of each area? All right. So you have to find 4 equal sides, some that they split into fourths. First of all, 1, 2, 3, 4. Okay, that could be it. 1, 2, 3, 4. That could be it. 1, 2, 3, 1, 2. Nope, that's 2 and 3. That's not 4, so it can't be that. And 1, 2, 3, 4. Okay, so far so good. All right, now it's 2/3 of an acre. So the 2/3, it needs to be filled in 2 out of 3. 1, 2, 3. 1, 2. 1, 2 out of 3. Okay, that makes sense. Split into fourths, and it has 2/3 filled in. Split into fourths, but it only has 1/3 filled in, so it can't be that. All right, this one, it's not even set up appropriately. It's not split into 2/3 because it needs to be 1, 2 out of 3, 1, 2 out of 3, or 1, 2 out of 3. Not this way. So this isn't right. So the only answer it can be is answer A. It's a very weird way to look at this, but it's interesting. All right, and the next one we're about to do, you've seen before. You've seen it probably, I think, on the first quiz you ever took in this class. All right, let's move up for it. Here we go. So this one right here, it says, the graph shows the number of slices of pizza sold each day for a whole week in the school cafeteria. So does this mean they sold only 2 slices? Let's look. One of these little slice things equals 10. So no, this is not 2. If you thought this was 2 slices, you will end up with the wrong answer. They'll have the option down here. I promise the option is down here for it. But it's not right. 10, 20, 20. 10, 20, 10. 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. All right, add them together. 50 and 50 is 100, 110, 120, 130, 140, 150. So 150 pizzas, slices. Each slice of pizza costs 50 cents. So times 0.5 or 0.50, doesn't matter. What is the total amount of money collected by the school during the week? All right, so we have to do that math. So we need to do 50 cents times 150. All right, well, this is a word problem. Technically, you will have a calculator for it. But just to keep ourselves sharp, I'm going to do it the old school way. 150 over 0.5 or just 0.5. If you did it 0.50, it'll still work out. It's just 2 decimal places you have to move at the end instead of 1. All right, 5 times 0 is 0. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. 150 times 0.5 is 750. Or is it? Because we didn't forget there is one number that is behind the decimal, so we have to go in one time. 75.0. $75. C. Not $7.50. Not $7.50. If you find 150 slices of pizza for $7.50, whatever you're doing, stop what you're doing. And you need to call, text, or email me so I can come get that deal, because that's a great deal. That's a great deal. I want that. 150 slices, we would have 2 pizza parties, and I'd pay $7.50. That's the best deal I'd ever get. So we would do that. All right. Keep going forward. Doing great. Last side of the last page with plenty of time to go. Oh. All right. Which are the percent and decimal equivalents for 3/5? First thing you can do with this one, which is really nice, skip count it. If you can't, you can divide. You can always divide. It's not a problem. 5 into 3.000 with a decimal on top. That's great. We'll do it that way this time, even though you could skip count and you'll get 6/10. 5 goes into 3, 0 times. 5 goes into 30, 6 times. All right, after you do your first division, then you multiply. 6 times 5, and you'll get 30. Now we get to subtract, and we get 0, and bring down 0. 5 goes into 0, 0 times. We're done. 0.6. Well, 0.6 is this guy. Let's see if it's also 60%. Go 1, 2. Yeah, 60%. So it would be D. 60% or 0.6. 60% or 0.6. Now it says which statement is true. If you'll look at these, you'll notice every single one of them has a whole number of 2. Well, comparing 2 against 2 doesn't matter. I mean, 2 is 2. It's not greater than or less than it is. All right, so we can ignore those. If you want to put a little line through them, go for it. I don't care. All right, boom, boom. Get rid of them. Don't want to look at them. They're done. All right, it's all about the fractions. If the whole numbers don't matter, then you look at the fractions. 3 times 1, 3. 2 times 2, 4. Is 4 less than 3? Is 4 less than 3? No, can't be that one. 5 times 2 is 10. 3 times 3 is 9. Is 9 greater than 10? Is 9 more than 10? No, no. All right, 4 times 2 is 8. 3 times 3 is 9. Is 9 less than 8?
No.
Nope. So it must be this last one. 3 times 3 is 9. 10 times 2 is 20. Is 20 greater than 9? Yep. So it has to be that one. Goes really fast. It's better than making it all percents. You know I like percents, but this is the one time that I found something that I think works better than turning everything into a percent. And that's doing the denominator times the opposite numerator. Denominator times the opposite numerator. And that's all you got to do. All right, this next one. It says, where is 0.75 shaded? All right, when we're looking at this one, yes. That's okay. D. Yeah, and let's look at it. So 0.75, that's in quarters. We all know quarters, 25, 50, 75, $1. All right, so split it up if you need to with lines of 3 lines. And that would give you your quarters. And if you look at it, well, this is less than 1/4, so it's less than 0.25. Can't be that. All right, this one is 0.25 or 25%, so can't be that. 50%, still not that. 75, 25, 50, 75. Very good. It would definitely be D. All right, now this next one, everybody's been getting wrong, and here's what you need to do with it. Turn them all into percents. Please don't be lazy. DBL, DBL. All right, don't be lazy. So 0.31, 31%. All right, 0.275, go 2 places over. That's 27.5%. All right, the rest of these, I'm not going to actually put the percent sign, but I'm going to go through and do the numbers really quickly. So 32.5, because you move it over 2 places. 32.5. 1, 2, 31. 1, 2, 32.5. You can see a lot of these repeat, so you get to know them. 27.5. 53.2. 31. 27.5, 31, 31, 32.5, 53.2, 32.5, 31, 32.5.
The time is now 3:26. Within the next 9 to 10 minutes, we're going to ask teachers to begin to curb releasing students from class. 6th grade teachers, we have a number of 6th graders in the hallways. Please do not release 6th graders out of your classes to go to the bathroom, to get water, unless you feel it is indeed necessary. At 3:35, we will lock the bathroom doors, but 8th grade bathrooms will remain open. Thank you very much. We have many students in the hallway, and we need your support to keep them out of the hallway. Thank you.
All right, now we can go through and actually compare them. So 31 is less than 27.5. Is that true? No, it's false, and we need ones that are true, 31 is not less than 27.5, so false. All right, is 32.5 greater than 31?
Yes.
Yeah. All right, 32.5, is it less than 27.5? Nope. Is 53.2 less than 31?
No.
No. Is 27.5 less than 31?
Yes.
Yep. Is 31 greater than 32.5? Nope. And is 53.2 greater than 32.5? Yes. And lastly, 31. Is it greater than 32? No, never. So it's those three. And if you would have had a fourth one, or if you only had two of them circled, you would get it wrong. You have to get those three, exactly those three, and nothing but. That's why it's worth making it a percent. So even if you're really good at decimals and you're able to get most of this with just doing the decimal comparisons, the chances are you could still easily miss one of them, just one of them. And that's all it takes. So don't miss any of them if you just make them all percents. It's worth the extra minute or two of your time, I promise. All right. Getting there, guys. Now we get to, it's not a lava block. It looks like a lava block, not a lava block. And that's because this is a 100 grid. This is a percent grid. This is 100% out of 100. If you count all the blocks and all, 100%. All right, so how many do we have? Let's see. One row of 10, 20, 30, 40, 41, 42, 43, 44, 45, 46, 47, 48. 48 out of 100. So let's look down here. There's 48 out of 100 or 48%. Same thing as 48%. So these two, cool. These two, yeah. 52, nope. 52, nope. So it can't be B. It can't be C. We're down to A or D. Now here's the problem. If I move this 2 decimal places away from my percent sign, would I get 4.8 or 0.48? 0.48, yeah. 4.8 would be 480%. That would mean I have 4 whole ones of these filled plus 8/10 of another one filled. Not true. Not true. So it has to be 0.48, which is D. D is the correct one. A is incorrect. All right, 61 over 10, 15.8. 0.079 and 65%. First thing I'm going to do, you know me, they're all going to be percent. Every single one of these going to be percent. It's worth it. So 61 tenths is the same as saying 610 out of 100. So 610%. So 610% versus this guy, 15.8. That means 1,500%. Think about it. Because it's a whole number. One whole is 100%. 15 wholes is 1,500%. All right, so we're going to go 2 places to the right. Still goes to the right. 1,580%. All right, this one still goes to the right. And that would just be 7.9%. And then 65% is 65%. Now it says descending order. Descending. Am I going up or down? Going down. Descending has the word, the letter D. Starts with the letter D. Descending down. Descending down. Means you got to start from the biggest number, though. So even though we point down, doesn't mean we start at the lowest number. It means we start at the biggest number. Which one would be my biggest one? 1580. 1,580%. Yes, if you got that on any test, you're good for the year because that's like 15 tests, right? Because if you got over 1,500%. All right, so that'd be really good. But yes, it would be the 1580, which we have to write it the way they wrote it, which was 15.8, because it won't know. The computer won't know about 1,580%. That's something we turned it into so we could compare it and understand it. All right, next one would be 610% or 61 over 10. All right, next one would be 65%, already written as percent, very helpful. And then the last one, 0.079, 7.9%, very small, very small. All right, now it says not a true statement. Not true, not true. We got to be careful with that. All right, 139 over 100, that is 139%. So let's see if this equals 139%. Go 2 places to the right. 1, 2. Put a percent sign. 1,390% is not 139%. So this one is not true. So this would be our correct answer. But let's just check the other ones first to make sure I didn't mess up. All right, 30%. The word percent means out of 100. 30 out of 100 is 30 out of 100. Makes sense. 6 over 10. Well, the rule is you can add a 0 to the top and bottom. As long as you're consistent, do it to the top and bottom. 60 over 100 equals 60 over 100. That's true. Okay. 2/3 is greater than or equal to 8/10. Let's find out. 2/3, skip count. 6, 9, 12. 2, 4, 6, 8. 8/12. So 2/3 is 8/12. It's equal to 8/12. 2/3 is greater than or equal to 8/12. So it's true. Even though you're like, wait a minute, it's not greater than 8/12. No, it's not. But if it's greater than or equal to, if one of those things are true, the whole statement is true. So this is still a true statement, even though it had that greater than sign, which is kind of pointless because it's not greater than. All right, so it has to be A. It's the only one that is not true. It's the only false one up there. All right, now we're on our last side of our last sheet. Doing an amazing job, guys. All right. Express a decimal. 3.5 is a fraction in simplest form and a percent. So fraction, decimal, percent of 3.5. All right, well, we got the decimal, 3.5. Now I want to turn it to a percent. I go 2 places towards where I'm going to put a percent sign to the right. 350%. All right, so I have 350%. Now I need it as a fraction. Well, the word percent means out of 100. So 350 over 100. All right, well, improper fraction. Denominator at the door, numerator in the house. 100 goes into 3, nope. Goes into 35, nope. But it goes into 350 3 times. 3 times 100, 300. Subtract, you get 50. So you have 3 and 50 100ths. 3 and 50 100ths. 3 and 50 out of 100. Now what you could look at and say, oh, greatest common factor out of 50 and 100 is 50. It's actually 50. But if you kept dividing it by 2, that's fine. If you keep trying other things, divide up by 5 on the top and bottom or by 10 on the top and bottom, you'll get there. It just takes you longer. Or a lot of people look at that and they know 50 is half of 100. So it's the same as saying 3 and 1/2. So 3 and 1/2. All right, of the 6th graders at Harrison Middle School, 20% walked to school. The word percent means out of 100. So 20 out of 100 went to school. All right, 2 out of 100? Nope, it's 20, so it can't be that. All right, 2 out of 20? Maybe if I simplified, I'm not sure. I'm just going to wait on that. All right, 20 out of 100. Yes. 20 out of 100. Oh, there it is. All right, no need to look back. That's it. That's my guide. I like it. Not 100 out of 20 because that would be an improper fraction. All right. And then our very last question. And this one, we will be converting to make it work. All right, first things first, go through and see how many shaded parts of each one of these if you want to get your numerators. Or find out how many in all if you just want your denominators. Or do both. So 1, 2, 3, 4, 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10. 4/10. Or 0.4 because that's my tenths column. Or 40%, as you know I like my percents. All right, now 2 out of 4. 2 out of 4. Or 0.5 or 50%. All right, now this next one looks a little scary. 1, 2, 3, 4, 5. So 5, got to be careful. This is the hard one. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of 12. Uh-oh. Denominator at the door, numerator in the house, because I don't know that one offhand. All right, 12 goes into 5, can't do it. I'm going to give myself a couple multiples. 12, 24, 36, 48, 60, 72. That should be good. All right, 12 goes into 50. 1, 2, 3, 4, 4 times. All right, so far so good. 4 times. 4 times 12 is 48. Subtract, you get 2, and you'll bring down 0. All right, now we'll go 12 into 20. We start back over at the cycle. Does McDonald's sell burgers? When you're done with your burgers, go back to does. All right, so 12 goes into 20 one time. 1 times 12 is 12, and you'll get 8. Bring down a 0. 12 goes into 80. 1, 2, 3, 4, 5, 6 times. 6 times 12 is 72. And you would get 8, which means you would get another 80, which means it would repeat. But I'm not really worried about it, because if I move it over 2 places, 41.6%. That's all I wanted. Got it, percent. That was the whole goal, get my percent. All right, 1, 2, 3, 3 out of 1, 2, 3, 4, 5, 6, 7, 8 out of 8. Which is 8 goes into 3, because I had another one that I don't know. And if I don't, I can't help it, can't fake it. Just got to work it. All right, 8 goes into 3, can't do it. 8 goes into 30, well, let me put a couple multiples down. 8 plus 8 is 16, plus 8 is 24, plus 8 is 32, plus 8 is 40, plus 8 is 48, plus 8 is 56. All right, this should be more than enough. All right, so 8 goes into 30, 1, 2, 3. 3 times. 3 times 8 is 24. Get 6, bring down 0. 8 goes into 60. 1, 2, 3, 4, 5, 6, 7 times. 7 times 8, 56. Subtract, you get 4. 40. 8 goes into 40 5 times. 5 times 8 is 40. Subtract, you get nothing. 0.375, or if you made it a percent, would be 37.5%. Now that we have the percents for all of them, 40, 50, 41.6, and 37.5, which one is my least amount? My least amount shaded. Yeah. Which is the smallest one up there?
14.
No, but look at the percents. I turned them into percents for a reason. If you're just going to look at these and kind of think about it, then you wouldn't need to do the math. You might have got it right too. Who knows? But looking at these, which is the smallest one? Which is the worst grade on the test?
D.
D. Well, not because D is the worst grade of A, B, C, and D, but also because D is 37.5%. Only a little over a third of this thing is shaded in. A little over a third, because a third is 33%. So it's a little over. So D. Great job.